Okay, I need to continue my graphs of sine and cosine lesson. There's a couple more things we need to talk about besides an amplitude change and a period change. And they are a phase shift and a vertical shift. So I'm going to have a phase shift if there is a C right here in my graph. And my formula for a phase shift is going to be simply C over B. I'm not going to use that, but that's what it is. And then my vertical shift is going to be D. And again, that's fine to know. I'm not going to come back and really use this whole idea of C, B, and D to find all of this stuff. I want to show you a different way of looking at these if there is a phase shift like we're looking at. Okay. And again, this is normally where I'd have you guys make up a problem, but I'm sitting in a room by myself, talking to myself, and working these. So I went ahead and did an example. So I'm going to do sine, we'll do y equals sine of x plus pi over 6 plus 2. I really want to show you what the phase shift and the vertical shift is going to do. So notice that my amplitude right here that we learned about yesterday, or on the previous video, is still going to be 1. And then the period is going to be 2 pi over b. Well, b is also 1, so that's not going to change. That's going to help me out some. What I'm going to do new on this is that I am going to take this part that's in parentheses, and I'm going to set it equal to 0. And that went crazy, didn't it? I don't know what this problem was. I meant to put a -2 there. If I put a +2, I apologize. I'm going to switch it to a -2 just so it matches my notes. And so what I can do now is I can solve this for x. Whenever I solve what's in parentheses for x, this is my phase shift. I about forgot the F in shift. That would have been bad. All right. That's my phase shift. Is whatever's what in parentheses is equal to 0. Solving it for x, that's my phase shift. And so what I'm going to end up doing is I posted another video about this. If you look in Google Classroom under the material, someone else doing this, maybe better than me. But what that's going to do is it's going to give me a starting point of where my sine graph is going to start, -pi over 6. What I would like to do is I would like to go back and just get the 5 nicest points in this first period that I can, and then just play connect the dots with them. Because eventually what we're going to see is a phase shift, a vertical shift, a period change, and an amplitude change, and it's going to be way too much to keep up with. So what I'm going to do up here on this green table up here is I'm going to find the 5 most important points that I can in order to get me to a graph that's going to get me full credit. So here we go. Now, since my period is 2 pi, what I'm going to do is I'm going to also take what is in parentheses right here, and I'm going to set it equal to 2 pi. I'm going to set it equal to where the period normally stops. And so for me, I'm always setting it equal to 0 and 2 pi, the period of regular sine and regular cosine. So it'll always be those two numbers. And so if I add pi over 6 to 2 pi, careful with that. I need a common denominator. That is going to, I'm going to subtract that. I'm sorry, subtract that off. That's going to give me 11 pi over 6. And so this 11 pi over 6, I'm going to put down here at the very bottom. Now, there's 2 ways to fill in these other numbers that I need. I know I'm not getting very nice numbers right now, and I apologize for that, but it's going to be okay. These nasty numbers are going to help me get some great numbers in a minute. And so the way that I work it is I do something called half-C's. What I do is I look at -1 pi over 6, and I look at 11 pi over 6, and I try to think what's halfway between negative 1 pi over 6, and 11 pi over 6. Will be 5 pi over 6. And so 5 pi over 6 is going to give me something nice. And then I do halfsies again. I think about, well, there's negative 1 right there, and let me erase that. There's negative 1, and then there's 5. What's halfway between negative 1 pi over 6 and 5 pi over 6? Well, that's going to be 2 pi over 6, which is just pi over 3. And I think, what's halfway between 5 and 11? That's a little bit easier to do halfway between 5 and 11. I know it's going to be 9 pi over 6. Halfway between 5, I say that. Am I wrong? 8 pi over 6. See, that's why we need math. All right, so Mr. Lovelady can do his math, right? 8. What happened? Where's this? What's going on? There we go. 8 pi over 6, which is just 4 pi over 3. Okay. So now, what I'm going to do is I'm going to take all these values and I'm going to plug them in to this x. So yeah, I'm not going to write all this out because I don't have nearly enough room. But yeah, that means I'm going to do negative pi over 6 plus pi over 6 and then subtract 2. Well, negative pi over 6 plus pi over 6 is 0. I'm just taking sine of 0. I'm going to get nice values on this. When I take sine of 0, that gives me 0. And I subtract 2, it gives me negative 2. So that means that if I come down, I'm gonna count by ones again on this. 1, negative 1. So this would be negative 2. So that means that at negative pi over 6, so I'm gonna go just to the left a little bit. I should be right here at negative 2. If you didn't quite get all that, it's okay. I'm gonna do it again. Because I'm going to take pi over 3 now. I'm going to plug it in for this x. If you need a calculator on this, I'm not going to take away your calculator. I might not let you use one of my graphing ones since it will just graph this for you. But pi over 3 plus pi over 6, well, that gives me pi over 2. That's just 30 degrees plus 60 degrees right there. 90 degrees. Sine of pi over 2 minus 2, that's going to give me negative 1. Okay, so at pi over 3, let's see, if that's negative pi over 6, we'll do pi over 3 right here. I'm at negative 1. Okay. So I counted by something that was a little different on this. I don't know if I'm going to have enough room, but I'm going to go with it. So 5 pi over 6. If I plug in 5 pi over 6 and I add pi over 6 to it, that just gives me sine of pi. Well, sine of pi is 0. So when I'm at 5 pi over 6, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5 pi over 6 right here. I'm back to negative 2. Okay. And I'm going to take 4 pi over 3. Plug that in. If you haven't noticed yet, I'm getting all my quadrant angles. 0, pi over 2, pi, and 3 pi over 2. And so, I got to subtract 2 from it. When I do sine of 3 pi over 2, that's going to be negative 1. That's going to end up giving me negative 3. So I'm going to have to come down a little bit more. Come down 1. And at 4 pi over 3, it's right there. Yeah, that's going to put me a point right here. And then 11 pi over 6. When I plug in 11 pi over 6 right here, and I add pi over 6 to it, that gives me 2 pi. Sine of 2 pi minus 2 is just going to be 0 minus 2. Yeah, I'm back to negative 2. I hope this graph looks a little familiar to you. I kind of have to extrapolate a little bit. If I connect those dots left to right, yeah, sure enough, that's my sine graph. It just got moved a little bit. It's not hovering over the x-axis anymore. Do me a favor. Let's label everything that's on my table. 11 pi over 6. And then from here, we're just going to keep the same motion and just extend it. Extend it through the next turn. That way I get 2 hills, 2 valleys. And when I look at this graph, that's going to be full credit. A lot going on there, I know, but that's going to be the graph. That will definitely take some practice. We'll get some practice on that. Okay, let's do one more together. I'm not going to have you do one on your own today. I'm wanting to keep this video kind of short, and these problems take a little bit. So let's do one more. Oh, we're going to do it on this one. Okay. I'm gonna throw in a little bit extra here. Let's do a cosine one. So we're hitting both. I'm going to throw a -3 right there. I skipped something, didn't I? Oh, we're doing this. Okay, sorry. So just kind of a review, everything that we've done from yesterday and today. If I'm looking to find the amplitude, I'm just going to take the absolute value of this A right there. Okay. To get the period, I am going to just do 2 pi over this B right here. To get the phase shift, I'm going to do, let's do this. Positive C over B. That's going to bring both of these down. Right? But like I just showed you on the last one, I do phase shift a little bit different. And to determine the midline, let's not even worry about that with this video. We'll come back to it if we need it. I don't think we need a midline. So let's go back and let's add a little bit to our phase shift and stuff. Okay, so let's do a cosine one. Y equals, I'm going to throw a -3. That's going to be kind of weird. That usually throws people off. Let's throw a 2x here and a -pi/2. This would be about as hard of a one as I would give you. I don't know if I'm going to give you any that has an A, B, C, and D. That's a lot to keep up with. It's a lot to grade. It's a lot to try to not mess up. So let's just take it a step at a time here. Let's come over here and get some vital information. My amplitude on this is going to be the absolute value of that -3, which is 3. That means from the middle, I'm going to go up 3, and I'm going to go down 3. Up 3, down 3. My period on this is going to be 2 pi over that 2. Oh, we had one like this on the last video. That's okay. My period on this is just going to be pi, right? So we know how to handle that. Let's see. Phase shift. I'm just going to come down here and do my phase shift right underneath, so I make sure I don't copy anything down wrong. Let's see, if I add pi over 2 over, and I divide by 2, see how that phase shift's kind of weird? Phase shift, also known as a horizontal shift. That would be my phase shift. So remember, what that means is that when I come up here and do my table, that I'm going to start my table at pi over 4. Now, where's my table going to end at? My table is going to end at, well, sine normally ends at 2 pi. I'll just take what's in parentheses, set it equal to 2 pi, what the period should be if I was graphing just cosine, and figure it out. So if I add pi over 2 to that, common denominator gives me 5 pi over 2. So my table's only going to go to 5 pi over 4. There is a formula I can use, and if you don't like the whole half-seas I'm about to do, there is a formula I can use that just says take pi divided by 4, and then that's how much you increase going all the way down to get each value. So I could just simply add pi over 4 to pi over 4, whatever that gives me, add that to pi over 4, add it to pi over 4, add it to pi over 4, until I get down here to the bottom. If you like that way, it's perfectly fine, because that's just going to give me 1 pi over 4, and then 2 pi over 4, and then 3 pi over 4, and then 4 pi over 4, and then 5 pi over 4. If you work it how we did on the last slide, if I just have the pi over 4 and the 5 pi over 4, and I do halfsies, hopefully you know halfway between 1 and 5 is 3. Halfway between 1 and 3 is 2 pi over 4. Halfway between 3 and 5 is 4 pi over 4. So on this video, I'm giving you two different ways to kind of construct this table. That's, I think, the hardest part is getting those x values, getting the right x values, so that whenever I plug them in, when I do plug in pi over 4, that's going to give me something nice. It doesn't look like it's going to. So if I take 2 times pi over 4, that gives me pi over 2. If I subtract pi over 2 from pi over 2, that gives me 0. Guys, if you construct your table right, you're going to get all your quadrant angles, a bunch of zeros and ones all the way through. In this case, I'm taking cosine of 0, that's 1. 1 times -3 is -3. You see where I'm at on this. So I'm just going to count 1, 2, 3, 1, 2, -3. And so my first point landed at, ooh, we got negative pi over 4. Let's just go back to the original negative pi over 4. And I'm going to call that -3. Let's use black. Kind of got in the way there. I'll figure it out. All right. Part of teaching in an empty room is that no one's there to correct you. Yes, positive pi over 4 is what we were using. You are correct. And it would land down here at -3. Good. All right, next we have pi over 2. And again, watch what happens when I plug in pi over 2. If I take pi over 2 and I multiply it by 2, pi over 2 times 2 just gives me pi. So yeah, I'm just taking pi minus half a pi. Well, that's pi over 2. Again, look, I'm getting quadrant angles right there. 0 and pi over 2. Cosine of pi over 2 is 0. 0 times anything is 0. So yeah, at pi over 2 right here, I landed at 0. All right, we're getting there. We're getting there. These tables take a little bit. These problems will take a little bit longer. 3 pi over 4. You know what? I've kind of figured out my pattern now. I know I'm just going to hit the next quadrant angle, which is pi. Cosine of pi is -1. So yeah, at pi right here, I should be at +3. 1, 2, 3. Okay, I'm kind of getting a scrunched together graph, which is fine. I halfway expected that because that's what this 2 is doing to my graph. Let's plug in pi. When I plug pi in for this x, I get 2 pi. 2 pi minus a pi over 2 is 3 pi over 2. Cosine of 3 pi over 2 is 0. So I'm back to 0. Do you see the cosine graph that's kind of forming? It came back to here. Where do you think the next one's going to be at? I bet you my next answer is -3. Now, me being the safety Steve that I am, I'm going to go ahead and plug in 5 pi over 4. Gives me 10 pi over 4, 5 pi over 2. If I subtract a pi over 2 from 5 pi over 2, I get 4 pi over 2, which is just going to be cosine of 2 pi. Look at all these quadrant angles. 0, pi over 2, pi. This ended up being 3 pi over 2, 2 pi. So yeah, I got my answer to be -3. Kind of bailed on labeling my stuff here, so let me go back and hit this 5 pi over 4. Okay. These got really close together. It's okay. All right, just extend it through the next curve. Hey, I got 2 hills and 2 valleys there. That's enough labeled on the x-axis to get me full credit. Feeling good about this one. It's going to take some practice. If I remember correctly, there's one in the homework where doing halfsies is tough. You're going to get some weird numbers on that x-axis. Work with it, work through it, put it on the board during class if you're not understanding it, okay? Now, I'm gonna try to get this done in the next 10 minutes, but you know what's more fun than working a problem forwards is working it backwards. So I assigned somewhere, I want you to work them backwards. So this is what my graph looks like. Looks like the graph's been shifted a little bit. Because look, this is called the midline right there. The midline's going to run halfway between your maxes and your mins. And so the whole thing got moved up. Man, I wish I wouldn't erase that last one. I forgot to hit something. All right. It'll be okay. I'll talk about it here. So I'm looking at it, and I have to figure out if I want to use sine or cosine. And then I have all these letters to fill in. I'll give you a hint. You won't fill them all in. Some of them will be 1. And so looking at this one, I have to decide whether I want to use sine or cosine. Let's think about the difference between sine and cosine. Sine, whenever I graph sine, sine likes to start right in the middle and go, while cosine likes to start on a hill. Look back at your last example. I can't bring it back up. I erased it. I dropped the ball on it. Look at what happened on the last one. We started down here, didn't we? That negative that was in front of the 3 on the last example just reflected my sine graph down. Same thing that's happening here. Since this graph is going to start on the y-axis in a valley, or if it was to start on a hill, I'm choosing cosine. If it starts in the middle, I'm using sine. Okay. So now I just have to fill everything in. A is going to be my amplitude. Remember, amplitude definition is half the distance between the max and the min. So I need to take this distance and cut it in half. Well, it's also just going to be the distance from the max to the midline, or the midline out. So in this case, the amplitude is going to be 1/2. Mr. Lovelace definition is, I'm looking at this midline, I'm going half up, I'm going 1/2 unit down, I'm good. Now, B, remember, I'm going to find B if there's a period change. Remember, B is equal to 2 pi over B. I'm sorry, period is equal to 2 pi over B. You could definitely move the hat and solve for B, but I'm just going to work with this one equation. So let's look at the period of this. The period that it takes to complete one full hill and then the rest of each half of the valley and get right back here where I started at is 2 pi. So there's no period change on this. If I move the hat, I get my B is just going to keep the same value, 1. So you don't have to put the 1 there. You can just throw an X. 1X if you need to. That's fine. C is going to be how far it shifted. That's kind of hard. This thing did not get shifted at all. It did not move left or right. It started right here on the axis. That's one way to look at it. Right? So I don't have to worry about a C. A C is going to be 0. It didn't move. And then a D is going to be where your midline is. That midline definition I missed earlier, it is just going to be where your midline is. So I took this whole sine or cosine graph and moved everything up 1/2 unit. And that's going to be my D. One thing I did miss on this before I let you try one is that this graph did get reflected. Remember, cosine normally started up here on the hill. The fact that it started on a valley this time means that I have to reflect it, which just is going to be a negative on my amplitude, and that reflects the whole graph. And this would be one answer I would accept that I think would be the easiest one to get to. All right, your turn. I'm going to let you try this one. You determine if it's sine or cosine, find amplitude, period, phase shift. Several answers I'll accept on this one. I'm going to work it the easiest way I know how while you hit pause. So go ahead and hit pause, and then we'll come back. I think you got a little bit easier one. Big thing on this one is I did use sine instead. Look at my y-axis right there. I'm starting in the middle. All right, it's not starting on a hill or valley, so I'm using sine instead. All right. As example 3. Let's work this one. Maybe. Hold on, I might skip this one. Let's work this one. This one's probably tougher than any of the ones I assigned in the homework. So let's just go through this one. I'll get it done in the next 5 minutes so that way you have a 30-minute video. I hope. I'm feeling a cosine on this one. And the reason is it didn't start on a hill or a valley. I know that, but it didn't start in the middle either. However, if I can just do this little bit of a phase shift right here, it's really easy to tell how far I shifted everything over. Now, one thing that kind of worries me is that there's no pi's right here on the x-axis. So that means I got a period change as well. Let's just go in order though. Let's find the amplitude first. Remember, amplitude A is just going to be the distance between the midline. Oh, where's the midline at? Looks like the midline's running right through the middle of here. That makes it so I can count 1, 2, 3 up, 1, 2, 3 down. There we go. Amplitude has to be 3. Okay. Next, let's find the period. Again, you just gotta know that period formula is gonna be 2 pi over b. Let's count how far it took it to complete one full period. By the time it goes all the way down, does this valley, and come back and completes the left side of the hill, that was 6 units to complete that period. If I move the hat, I know, probably someone's watching this like, what is move the hat? You're not in my room, kind of missed that story. We are just moving the hat on there. It means something to us. But what that does is it gives me a value of b. B is going to be pi over 3. Throw my x after it. I have a phase shift on this one. Ugh. I dread that phase shift, so I'm going to come back to it later because I'm feeling my vertical shift's going to be really easy to find. I came down 2 units, right? So my midline's at -2. That is going to be my vertical shift. Let's talk about phase shift. This is the only time I use that phase shift formula. If I'm using my phase shift formula, remember I said that it is going to be C over B. Well, I know what my phase shift is. My phase shift, I went 1 unit to the right. C is what I don't know, but guess what? I just found B a while ago. I said that B was going to be pi over 3. So again, I can multiply both sides by pi over 3 to clear it of fractions, and I'm taking pi over 3 times 1, which is going to be pi over 3, and that tells me my C value that I'm going to put here. Now, it's inside parentheses, so it's opposite. So all that is still true from pre-calc A. And so I've tried to be really straightforward with that. So think about it, it's moving to the right. It's actually moving right 1 unit, but since it's moving to the right, it's going to be opposite on this, on the sine. Like I said, that's probably messier than any of the ones that I assigned, but go ahead and give those a crack. We'll try to work those. You don't have many to do. And so any of those you're having trouble on, let's get them on the board. And oh, let me show you my cartoon here. All right. Good luck, guys. And let me know if I can help in any way.